So heat and temperature change are related by this equation. The heat, that's the amount of energy, equals the mass of the substance times its specific heat capacity times the temperature change. So Q equals mc delta T. It's all spread out. It's a little hard to see. Q equals mc delta T. Q equals MCAT. One way to remember that. So Q is the heat in joules, M is the mass in grams, C is the specific heat capacity, joules per gram degree Celsius. Delta T, delta, that triangle is the capital letter, Greek letter delta. It means change in. And by convention, delta is always the final minus the initial. So if the temperature goes up, the final temperature is higher than the initial, and the change in temperature is positive. Going up is positive, going down is negative. If the final temperature is lower because it's cooling down, then it's a negative temperature change. You find a copper penny in the snow. What's that? And pick it up. How much heat is absorbed by the penny as it warms from the temperature of the snow, minus 5 degrees Celsius, to the temperature of your body, 37 degrees Celsius? Assume the penny is pure copper and has a mass of 3.10 grams. You can find the heat capacity of copper in table 3.4, page 71. I forget which edition of the book that is. It's one of them. Or we can find it right there, copper. So this is a specific heat capacity of copper, specifically, 0.385 joules per gram degree Celsius. So since they told us to go look for that, C, 0.385 joules. Write this as a vertical fraction, grams dot degrees Celsius. Let's go back then and find all these numbers here. We have minus 5 degrees. And we have 37 degrees Celsius. Bless you. And we have 3.10 grams. So this is a problem that has an equation, right? Q equals mc delta T. So we should identify what these numbers are in terms of the variable in this equation. Well, this one, 3.10 grams, that's the mass, right? So that's M. There are two temperatures. So we need to remember, I'll write it up here, delta T is the final temperature minus the initial temperature. So these are temperatures. We need to identify which is the initial temperature and which is the final. Well, it goes from minus 5 to 37. So from, that's the initial, to is final. So it goes from this to that. So we could calculate delta T. It's the final temperature minus the initial temperature, 37.0 degrees Celsius minus negative 5. And yes, you can subtract a negative. Watch out for those negatives. They're pesky. 37 minus negative 5, 42. I'm subtracting there. This is 0.0, that's 0.0. My calculator just shows me 4.2. But I should have one decimal place, so I need to put 0.0 degrees Celsius. The question is, how much heat? That's Q. So I don't have to rearrange this equation. I'm looking for Q. I looked up C. I was given mass. I was given the information to find delta T. So Q equals the mass, 3.10 grams. Write the stinking units in your problem. Just do it. 3.10. And then C, 0.385 joules over grams degrees Celsius. And delta T, 42.0 degrees Celsius. Check the units. Here I have gram, that's in the numerator, and I have gram in the denominator. Those cancel out. Here I have degrees Celsius in the numerator, and that's in the denominator, degrees Celsius. Those cancel out. I'm left with the unit of joule, which is a unit of heat, so that's a good sign. 3.1 times 0.385 times 42 equals, how many sig figs should this answer have? 3. Everything in there has 3. This temperature only had 2, but because we were adding and subtracting, the number of sig figs in there changed, and that's okay. So 50.127, the unit is joules, and so that rounds to 50.1 joules of heat. Any questions? My question is, how many slides do I have left? Oh, good, only 2. Temperature of a lead fishing weight rises from 26 to 38 as it absorbs 11.3 joules of heat. What's the mass of the fishing weight in grams? My question is, why not just stick it on a balance and weigh the stupid thing? But we can't. Write down the numbers. 26 degrees Celsius, 38 degrees Celsius, 11.3 joules. Well, these are temperatures, obviously. We'll call those T. We need the initial and the final. So from 26 to 38. 38 is the final, and 26 is the initial. 11.3. In the Q equals MC delta T, what is that? It's Q. Q is heat. So this is Q. And we could calculate delta T. Delta T is going to be the final, 38, minus the initial, 12. I need the mass. So I'm going to have to rearrange this. So if I want mass by itself, I'm going to divide both sides by C. C cancels. And I'm going to divide by delta T on both sides. And delta T cancels. So I get M is equal to Q over C times delta T. What am I missing? I'm missing the specific heat capacity, C. I was told it was a lead fishing weight, so I can go look this up. I need the specific heat capacity of lead, 0.128. So C equals 0.128 joules per gram degrees Celsius. So now I can put these in here. So Q, 11.3 joules. Down here I've got 0.128 joules per gram degrees Celsius, and I've got 12 degrees Celsius. The joules cancel, degrees Celsius cancel. I end up with a unit that's 1 over gram, which is gram. When you're doing this on your calculator, be careful. If you really want to do 11.3 divided by 0.128 times 12, you need to put parentheses around that. What I do is I divide. I'm dividing by 0.128 and I'm dividing by 12. So 11.3 divided by 0.128 divided by 12. So the mass, and this is going to have 2 sig figs, 7.356 grams, or 7.4 grams. If you cannot get from this equation to this on your calculator, come talk to me and I'll have a word with your calculator. It's your calculator's fault. It's not your fault. It's your calculator's fault. We're not going to worry about that one. Let's say we're done. Yay, we're done.